All right, so this is section 12, sine, cosine, and tangent. Those words are for trigonometry. So as I said a little bit ago, we're going to study trigonometry to solve the second half of the unit problem, and we're going to focus on right triangles. So for right triangles, trigonometry studies the relationships among the acute angles and their side lengths. Okay, so we're focusing on the acute angles of right triangles and the side lengths on right triangles. So Pythagorean theorem, it allowed us to find a missing side if we had two sides. Trigonometry is like one step above that. It allows us to find missing sides, but you only need one angle and a side, and then you can find another side. So let's revisit here what we were just talking about with hypotenuse, adjacent, and opposites. So if I'm looking at example 1, it says label the hypotenuse as HYP, the opposite as OPP, and the adjacent as ADJ for the indicated angle. So you have to look here, guys and gals, at this letter that it tells us. It tells us to use angle A. So from angle A, again, the first thing you always want to label is the hypotenuse. Well, the hypotenuse, as it doesn't matter what angle I'm using, it's always the hypotenuse. But once you label the hypotenuse from angle A, we want to label the opposite. And then the adjacent is what you label last. And again, we label the adjacent last because the hypotenuse also looks like an adjacent. And we just want to make sure that we get it right every time. And today we're going to use these correlations, these opposite sides, the adjacent sides, the hypotenuses. So it might seem pretty basic right now just labeling these, but we want to be able to make sure that we get it right and understand that to move on to the next part. So we'll do the one more together from angle T. First, again, we always label the hypotenuse. So I find my right angle symbol. I go across. That's my hypotenuse. From angle T, then my opposite is 33 because it's over. So the O and O, opposite means go over the triangle. And then adjacent is next to it. So I want you to take 30 seconds here or so and label the hypotenuse, opposite, and adjacent on C and D, please. All right, let's go ahead and see how we did. From angle C, and sometimes I'll put like an arc there so I know that that's visually the one that I'm working with. Find my right angle. 10 is my hypotenuse. From over opposite is the 6, and adjacent is the 8. And on number 4, from angle T, so I'll put an arc here knowing that I'm using it. From the right angle, there's 10 is my hypotenuse. Across from T is 8 for my opposite, and adjacent is 6. Okay, now that we have this easy peasy stuff going, we're now going to learn what in the world does this opposite, adjacent, hypotenuse, what does that mean? Okay, so here we go. So we have ratios that are always true. Side lengths divided by other side lengths. Okay, so we're going to say let triangle ABC be a right triangle as shown here. And the trigonomic ratios, sine, cosine, and tangent of A are defined as follows. So first of all, would you please go ahead and label from angle A one more time, the opposite, the hypotenuse, and the adjacent. Now, the sine from angle A is always equal to the opposite divided by the hypotenuse. So it says the sine of angle A is the ratio of opposite and hypotenuse. That means we're going to divide. Ratio, we're going to write it as a fraction. Sine is always going to be equal to the opposite divided by the hypotenuse. Cosine is going to be equal to the adjacent side divided by the hypotenuse. And tangent is equal to the, from angle A, is equal to the ratio of opposite and adjacent. The opposite divided by the adjacent. Sine, cosine, and tangent. These are the trigonomic functions. These are the words that are kind of abbreviated on your calculator that you've been maybe saying sin, cos, and tan, but it's sine, cosine, and tangent. Okay? So I have a mnemonic device to help us remember these, that sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. See the letters here? Tangent is the opposite divided by the adjacent. And we read this as SOHCAHTOA. Can you say that, please? SOHCAHTOA. One more time. SOHCAHTOA. Now, some people will say SOHCOHTOA, but that doesn't help us. It needs to be SOHCAHTOA. And this is how we can write it down. Sine of A is equal to the opposite divided by the hypotenuse. Cosine of A is equal to adjacent divided by hypotenuse. And tangent is equal to opposite divided by adjacent. It's really important that you have the equal sign here because these are equations that are true. I have no idea who made up SOHCAHTOA as a mnemonic device. It was around when I was in school. It was helpful, but you have to be able to repeat it to yourself a few times and make it mean something to you so that you can actually then apply it. I will reference it quite often. So now, if you can see, this is why we had these words, opposite, adjacent, hypotenuse. Okay, we need to be able to identify them. So let's go ahead and practice. So I have this triangle here, PQR, and it says write or find the sine, cosine, and tangent from angle P. So this is those words abbreviated, sine, cosine, and tangent from angle P. So put an arc at angle P. And we first, to write these fractions, you want to label the hypotenuse. Okay. From angle P, the opposite, and from angle P, the adjacent. Okay, so we're going to write these answers as fractions. So sine of P, if I use SOHCAHTOA, it says SOH. So sine is equal to the opposite divided by the hypotenuse. Opposite side is 15. Hypotenuse is 17. So we're going to write this as 15 over 17. Now let's say that this was 15 over 20 and there was something to reduce there, then we would want to. Cosine from angle P. C-A-H. Adjacent divided by hypotenuse. So we're going to write 8 over 17. And tangent is TOA, opposite divided by adjacent, 15 over 8. Now sometimes tangent could be an improper fraction like this, and that's okay where the numerator is bigger than the denominator. Okay? Nothing to reduce here. Let's go to the next example. I would like you to go ahead and try this one. Go ahead and mark that we're using angle W. Label the hypotenuse, the adjacent, hypotenuse, opposite, and then adjacent. Then I want you to see if you can write the three fractions that go along with it. All right, so let's go ahead and check and see how we did. On this triangle, we know that 30 is our hypotenuse. The opposite side is 18 from W, and 24 is the adjacent. Can I have a volunteer to share what they wrote for sine of W? Josh.
15 over 17.
On number 2? I think you were looking at number 1.
Oh, yeah, 18 over 30.
Okay, thank you. Good. And does that reduce?
Yeah,
9 over 15? Oh, I think it even goes lower. 6 goes in to there, 3/5. All right, 3/5. What about cosine of W? Tyler?
24 over 30.
Good. And that reduces 4/5. And tangent of W. Carson, what'd you get?
18 over 24.
Good. And would reduce to 3/4. Okay. Any questions over that? Okay. So this is what we want to be able to do today. Not necessarily write all three fractions every time, but just have a problem that looks like this. On example 3a, what's the sine of C? Find C on your triangle, label your hypotenuse, your opposite, and your adjacent, and then write the fraction. Sine. What is sine? What two sides?
Ratio, opposite, and hypotenuse.
Good. Okay, so whenever you see sine, I want you to say so to yourself. OH. So we're going to write 12 over 13. What about B? Cosine of Q. Mark angle Q. Label your hypotenuse, your opposite, and your adjacent. Cosine uses what two sides? Good. So say ka to yourself. So ka. AH. Adjacent hypotenuse. So we have 36 over 45. Reduces to good. Okay. So what do we have? 4 examples left. Why don't you guys go ahead and try C, D, E, and F. Go ahead and do C, D, E, and F, and then we'll discuss. All right, let's go ahead and check these answers. We're about done here. So cosine of x on example C, I marked angle x, labeled hypotenuse, opposite, and adjacent. Cosine, I'm thinking ka. So I went to the adjacent side and the hypotenuse. 48 over 52. Does that reduce? 12/13. Is that what you said? Good. And on D, from angle O, I have opposite, hypotenuse, adjacent. Tangent is TOA, so I'm going to write 28 over 45. That one does not, though, right? Does not reduce. And E, from angle V, I have hypotenuse, opposite, adjacent. I see sine. I'm telling myself, so opposite and hypotenuse, I have 32 over 40. 4/5. And on the last example here on F, I have sine of angle D, which again, I think so. And my opposite and hypotenuse is 20 over 25. Again, reduces to 4/5. Okay. Now, the last thing here I want to talk to you about is, I know we're all anxious to know, how do these abbreviations work on our calculator? Okay. So you do not have to have a graphing calculator. You can have just the regular TI-30XSI, okay? And I'm going to show you, though, we have to pay attention to a special setting if we're on the graphing calculator. So go ahead and turn on your calculator if you haven't done so. And when I turn on my basic calculator, I see on the screen 3 letters that say DEG. That means that I'm in degree mode, okay? And if you have a non-graphing calculator, hopefully you have a D or DEG on your screen. There are other modes. So when we use a ruler, we could measure in inches and we could measure in centimeters. It's like the metric system versus standard, okay? Well, on the graphing calculator, there are 2 different modes. So what I need you to do, if you have the yellow graphing calculator, is I need you to hit second mode. Or excuse me, just hit mode. Don't hit second first, just hit mode. And if your calculator has been reset, or if somebody hasn't changed it yet, the default about 3 lines down is in radians. But you need it to be in degrees. So you would arrow over above the word degree and hit enter. If you are not in degree mode, you won't get the right answers because it's going to be measuring in a different value. Okay? So unless someone resets the calculator, remember the graphing calculator, you can reset it by hitting second plus sign 712. Anytime anybody resets the calculator, it goes back to radians. So before quizzes and tests, I will try to remember and tell you, like, hey guys, make sure you're in degree mode before we get started. Okay? So we want to be in degree mode. And as long as nobody resets the calculator, it should stay in degree mode. All right. With that being said, let's just practice. So if you are in this screen here, this is where you hit second quit or second mode to quit out. So I'm going to clear all this out of my screen. And we're just going to practice typing these in. So what is the first one? Sine of 46 degrees. So sine, you just hit that button on your screen. It opens a parenthesis for you, sine of 46. All we're doing here is making sure your calculator is getting the right numbers. So you should be getting 0.179339. If you do not get that, let me know so I can help you with your calculator. And so you're going to write that down. It says to 2 decimal places, hundredths place. So we're going to write 0.72 in your note packet. Then we're going to type in cosine of 17. And on cosine of 17, you should be getting 0.956304. So we're going to write 0.96 because that's going to round up. And the last one here, we have tangent of 16. If at any point you are doing trigonometry on that blue and gray calculator, think it's a special Texas Instrument, sometimes you're going to get a radical here or a square root sign, like 2 square root of 3 or something like that. All you have to do is hit that decimal button. It's just giving you the exact answer. Okay, I think that's the square root of 3 is what your calculator probably just told you. So then just hit that double arrow button to get the decimal. Okay? All right, guys and gals, that concludes these notes. Let's just think about what do these decimals mean real quick. So do you agree that we said sine today equals the opposite divided by the hypotenuse? So on a triangle that has a 46-degree angle, the opposite divided by the hypotenuse is always going to reduce down to 0.719. On a triangle that has a 17-degree angle, the adjacent divided by the hypotenuse is 0.956, and that's always true. So the calculator is going to help us with these ratios that are always true when we solve in the next lesson. Okay?